This panel is with Melrose, Brian Hendricks, Director of Emerging Technology and High Performance Computing, and our guest, Greg Jones, who is the Director of Federal Advanced Programs for Source Code. They will be discussing digital twinning and its important role in the advancement of the aerospace industry. Brian's drive for innovation makes him a key player in exploring and implementing new solutions for emerging technologies. Let's all welcome Brian Hendricks.
Thanks, Suzette. Good to be here. The good doctor was talking about extroverted engineers. I felt particularly attacked by that. Anyway, so I'd like to welcome Greg to the stage. Like Suzette said, he's the Director of Federal Advanced Programs at Source Code. He leads innovation at the intersection of AI, edge compute, and national defense, with nearly 20 years of experience developing advanced tech for the Department of Defense, including AI-enabled drones, geospatial intelligence systems. Greg brings deep expertise in digital twinning for mission-critical environments, and today he'll share some insights on the transformative power of digital twins in the future of aerospace. Thanks for joining us, Greg.
Thanks for having me.
All right, so this is kind of for the audience, like who here knows or thinks they know what a digital twin is? So like a small percentage. All right, so for Greg, for those in the audience today who are unfamiliar with what a digital twin is and maybe how that's different than in manufacturing, what they might be used to is like a simulation. What do you think you can kind of explain that for them?
Absolutely. So a digital twin is a virtual replica of a real-world system, process, or object. And one of the things what differentiates a digital twin from a simulation is the digital twin is constantly evolving and getting information back from the real-world asset, object, or process, and incorporating that into a longer life cycle for whatever that process is, that object is, things like that. So an example would be GE for all of their airplane engines. Every single airplane engine that they're building now, they have a digital twin for that, not just one for all of their engines, literally one down to the serial number for every single engine. So whenever that engine is flying around the world, they're able to sit there and have real-world monitoring in a digital way to sit there and do things like predicting, failure, things like that, so that they can proactively address that. And that long-term reduces a lot of costs, support, maintenance, things like that. Simulation is more kind of a what-if type of thing, that if you're looking at, if this condition happens, how will the object behave? Versus the digital twin is going to last the entire lifetime of that system or object.
Awesome, thanks. So given your background and expertise, how do you see digital twinning helping shape the future of aerospace?
I think one of the things that's going to be a constant theme from the earlier conversation and us is anything that reduces time to decision, time to production, or where you find values in digital twinning. Even the government who typically is averse to always engaging what some of the best practices are within the commercial area. You're seeing that, so December 2024, the U.S. Air Force stood up their own digital twinning operation at Wright-Patterson Air Force Base, and that was to address the F-35 program that was tended to be over budget, behind schedule, things like that. And they were trying to move into more of the modern era with things like they're doing with the B-21, where they've actually had digital twinning, which reduces your need for prototyping. Also, your first pass of when you actually go to build something has about a 75% improvement in what that end performance is. So you're going to see a lot of that across that's now really being adopted by the government, but especially within the companies that are working here, that are able to sit there and reduce their costs, because you want to win the government money, but you want to be, you don't have unlimited funds. So the more that you're able to sit there and deliver a condensed time to decision, reduce your exposure in what you're spending, and present a product, whether it's to the government, private sector, things like that, digital twinning is going to be very valuable. Another example out of Mojave would be a lot of your hypersonic companies that are doing things like that. Hypersonics kind of expensive, and then when you look at, a company like Stratolaunch, that it's got these gigantic planes that they're launching things from, being able to reduce the amount of times that you have to go do that and that you have a better success rate, all leads to, time to decision, time to market, time to deliver for whatever that government customer may be asking you to do. So I think it's a really exciting time for investment and what we're seeing out of the private sector. Another company, out here in California, a lot of people have heard of, Anduril, that, instead of the F-35 that, took, 9-10 years, Anduril's got, a self, non-piloted, autonomous jet that they have, actually flown at this point. So you're seeing a lot of that type of thing in the private sector that's super exciting, especially around the coalition of folks that are doing here. The government has really, some of the things we talked about earlier is previously you had, DARPA tied to the internet or, space or even nuclear that all were able to kind of in Kennedy's, talk at Rice, talk about, we do these things because they're hard. That's one of the things that's very famous from the speech, but it was more why America needed to lead and the guidance for the broader, humanity of what we're trying to do there. And the thing that came somewhat out of the left field was artificial intelligence now dropping on this, that came out of the private sector and being driven by any number of companies out here. And you're seeing just the rapid advancement of that the government already had trouble keeping up with a lot of other things, but they don't have that ability to wrap their hands around it. So that public-private partnership in everything around, AI, digital twinning is going to be very critical. And then last thing, circling back to the Chinese Communist Party, one of the things that's going to be very beneficial for us, hopefully in artificial intelligence, is we don't physically have the number of human beings and manpower to compete with a company with the country with the resources like China. So being able to have the things, the next generation of AI where we're going now, that's what's called agentic AI, that is like multiple personal assistants, that's now going back and reasoning. It's not the one-shot chat GPT spit out a wedding seating chart or something like that, but then now goes and goes, all right, well, it thinks through, reasons the process, and then generates a multifaceted answer. So I think there's a lot of things that, and I think it was Churchill that said, you can always count on Americans to do the right thing after they've exhausted all other options. I think you now have that definitive, the 2027 timeline that was brought up, of that type of timeline, and now a more near-term, near-peer adversary in the Chinese Communist Party that is moving in one direction, and there's an onus, public and private, to really how are we going to address that? How are we going to compete with that in a much more finite time? And the exciting thing is you're seeing government where they're still not as fast as we'd like to be, but the idea of wanting to collaborate with private sector is really coming on strong, and I think that's an exciting time and a lot of opportunity within this, as we talked about, seeing 200 launches, 400 launches, things like that, and the companies out of El Segundo. You're seeing a lot of the non-traditional defense contractors that you're always going to have the big five, Lockheeds, Northrops, things like that. But now you're seeing the Andurils, the Palantir, all the El Segundo stuff that's really coming up, all the Mojave stuff, Stratolaunch, and any number of the hypersonics. So it's a real exciting time, and moving very, very fast. Where you see the artificial intelligence stuff now, it's Grok or OpenAI. It was like, every year we'll have a new model. Now it's literally this summer you've got one leapfrogging another, and it being able to keep up with all of it and advancements is an exciting time.
So one of the things I wanted to touch on, I know we have a lot of actual manufacturers here, people that make physical stuff, and I know we talk about digital twins, GE, we'll make a digital twin of this engine that's built, and we'll get real-time data and figure out predictive failure models and stuff like that. But I think what might be real interesting for the audience is digital twins in manufacturing, in the manufacturing space. And because of the difference between a simulation, where you're simulating a thing on an object or a single process, and digital twins, where we're taking a whole collection of processes as a whole and kind of analyzing the entire system. There's some real neat use cases for digital twins on the manufacturing floor. So if you make a digital twin, say, of your factory, right? For everything from where the machines are placed, where the humans are placed, where your parts bins are, what your stock ordering levels look like. Even if you, for example, make 5,000 different products with your same amount of tooling, like what is the way that you can best optimize making those 5,000 products and how those run across your assembly floor? It can be a really great use for digital twinning. You can find you some real like operational efficiencies and cost savings. So I wonder if you could talk on that a little bit.
Absolutely. And to your point, everything that we're doing is getting more and more complicated. So being able to sit there and have a digital twin of your factory, a lot of times you're going to be power constrained. It improves safety. And then, as I mentioned, where you've got a 75% improvement on process. And instead of running off a large assembly line and then going, I've got a manufacturing flaw after I noticed it 300 in, after I've sent it off to process, after I may have already integrated into 5 other things, you're able to sit there and identify that in a real-time type of capacity with that digital twin, where you immediately are able to go in, correct that process before it's been integrated into a larger system, rather than, harking back to F-35, of where you get something and then you have planned for 2, 3 years, 4 years on this large block system upgrade, get in there and there's some subcomponent that's going to cause that entire block upgrade to have tremendous delays. So being able to identify it in real time or near real time is a tremendous value, and being able to do predictive maintenance when you're able to sit there and go, all right, I know that this particular widget seems to have a higher failure rate, or what that is. So to keep that 24/7, 365 manufacturing type of process going, the predictive analytics that you're able to layer on with all of that information is very, very valuable.
So a little source code plug here. So you have a cool product called Griff, kind of like a little supercomputer in the box. How does that kind of fit into a digital twin workflow, and how can it help improve efficiencies and optimizations at the edge?
Sure. We'll use a couple of examples. So one of them that we're working with the Air Force on is traditionally, if you have a lot of advanced components and everything, it's all right, I see this fail, go break out a big manual, look through and says turn this screw half a turn this way. Being able to sit there and do that where you've got it at austere airfields, and you're able to use things like VR headsets with a full digital twin, where you're able to sit there and have that maintenance technician practice ahead of time before they're physically messing with a multi-billion-dollar, $100 million plus jet, and learning what those 2 or 3 steps are to sit there and do that. That's one of them. Another one, again, harking back to the near peer adversary with the Chinese Communist Party, is as we look at Taiwan, it's a very different war than we've been involved in the past, and that you've got an adversary you've seen Russia and China both where they're going in and ripping up all of the undersea cables, things like that, so that they're going to try to the clouds are great, but if the cloud's not there, you don't want to have be dead in the water in a lot of austere environments. So similar type of thing of being able to do a digital twin of say half a city, so that your soldiers are very familiar with what they're looking for when they go in there. It's things that they've seen before. It's not something coming out of the blue. So being able to make people familiar with things like that is something we're doing on the geospatial side, where you can take that, put it where it's disconnected from the broader internet, or you're able to download updates. So if you have a city that's evolving, changing, or based on whatever actions you're taking in there, that digital twin can incorporate that, and then they know what assets they have available to call on, things like that. So definitely digital twinning both at the edge and then also for development process of being able to get the technologies out to our warfighter, out to our soldiers, out to our operators in a condensed time with that 2027 timeline is very, very valuable.
Amazing. Brian, I have a question for you. Based on the balance of the 4, source code being one of the vendors downstairs, the other, how do you, since you helped me select who to reach out to for our vendors downstairs, how do you see Melrose and Space Return benefiting, and why did you select Geyser, Cumulo, and SonicWall to be the critical members downstairs as well as source code?
Sure. So I'll start with Cumulo. They're great cloud native, on-prem, edge, data center, file storage, fast, efficient, scalable. Every company that's going to do anything in the modern time is going to generate a lot of data. You're going to need a place to store that data. You're going to need a place to analyze that data. And you're going to need to take that data and pipe it into stuff like the Griff, which is going to enable you to use your AI workloads, right? So that's two kind of pieces of the pie right there. Geyser, cloud native, tape-based archive, super secure, cloud first data archive. So once you get all that big data that you've got on your Cumulo, you feed it through your AI, you're going to generate a bunch of stuff. You're going to need to archive some of that. Maybe you're going to use it later. Maybe you just need to safely store it in a secure manner that's accessible from anywhere in the world. That's going to be Geyser. And then you got to protect all that data. It's your IP, right? That's your bread and butter. That's what makes us all able to pay the bills. And SonicWall is the provider that provides network security, zero trust frameworks, firewalls, endpoint protection to help secure the data that lives inside of your organization.